Hope you're doing well. Oh God. What is this lighting? Maybe this wasn't a good idea. Hey Seth. I don't know. It's hard to tell when it's so small. Just gonna let it ride. Um God, when I lean in, I feel like I'm way too shiny. I don't know if this is gonna be the play. It kind of hurts my eyes too. Ugh. Oh God. Actually, how does that look? Is that less shiny? It's still kind of shiny. Well, I'm getting distracted. Okay, that's way too shiny. I was messing with my lighting, and it was not working out how I hoped. I thought it looked good, and then it didn't. So I'll just go back to how I usually do it. Oh, but now I don't like this either. Dude, why is my face so... Why do I have them both on at the same time? They're coming from the same angle, which I should not probably have, but... You know what? Okay. I'm gonna... I don't know. I'm going with this, I think. Maybe less yellow, though. Maybe a little more yellow with that, though. Okay. I was messing with this before the stream. I thought I got it into a place where I liked it, and then once I actually got on stream, it's like, I don't know if I like this. Anyway. Um... Let me, I don't know. I guess I'm going to do some more mechanics studying. I'm not sure what else to do right now, to be honest. So I'll wait for, wait to see if someone has a homework question. So I ended on 15 last time. Oh God, I remember I started thinking about 16. I don't know what to think about it still. I don't really get the questions asking. Let's bring it in though and keep thinking about it. Okay. So I want my blanket. It's cool. Okay, so block with mass m rests on a wedge with mass m and angle theta, which lies on a table, as shown in figure 4.27. Also reserve frictionless. The block is constrained to move vertically. Is this Father Christmas? Me? My beard isn't white. Not yet, at least. Or gray. White, same thing. Oh yeah, how does... Okay, I was thinking I should also up, like, the thickness of the pen strokes. Because the thicker pen stroke, I think it probably looks better on stream, I bet. Like, more readable. I don't know. I'll always try it. Young father? You know, I'll take it. Oh, welcome back, Eldritch. Oh, or bye. I don't know if you're coming or going, but thanks for being here no matter what. So the thing I don't quite understand about this question is why, like, what is the acceleration of the wedge? But isn't this block clearly just stationary? That's what I feel like I'm not understanding here. Oh, all right. Good night, Eldritch. Thank you for saying hi. Congrats on the first again. And so they say the block is constrained to move vertically by means of a wall on its left side. But it's certainly not just going to start floating directly upwards or like drilling directly down through the ground. And so I really don't understand what this question is asking. Oh, the acceleration of the wedge. I was thinking about the acceleration of the block of mass big M. Oh! No, I'm just stupid, dude. Okay. Mystery solved. Okay, I get it. They're asking about the frickin' triangle wedge down here, not the nearly rectangle, like the trapezoid there. Okay. There we go. That makes more sense. So this big block, or this massive block, this block of mass big, oh my god, is basically pushing down on that triangular wedge. And so this wedge is going to be slipping out that way since there's no friction. I know it's going to be helpful, but we know that this angle up here is pi over 2 minus theta. And those are both right angles. And so we can figure out the other angle there. I don't know if we need it though, so let's not bother yet. We also know this is the same angle as that. Oh my god. Wait. This is a sub alert. Did my... What? It's so long. Oh, you did both. What the hell? I was so weirded out. Thank you so much, Hardlock. The simultaneous tier 2 and the $15. I didn't even show up in my freaking activity feed. There it is. Thank you so much. 16 months. Yeah, you hacked the system. I appreciate you, dude. We gotta get another Phasmo session going or something at some point. God, those freaking Huskies. Love them. The angle that's pi over 2 minus theta, it's because if you imagine the triangular wedge moving outward to the left, there will eventually be a point where it's perfectly lined up, where that's the triangle wedge, that's the block on top, and this angle here is still theta, but now they form a right angle. So the remaining bit of the angle must be pi over 2 minus theta. I don't know if this is like helpful yet, but I'm just kind of thinking about the geometry before I'm getting too deep in the problem itself. How do you know the right angles? Well, the ground is flat and the left edge of the block on top is vertical, so those are perpendicular. We can assume it's flat, Seth. They're not going to give us a curved surface. I think we need center of mass approach this problem, Scrim Pool says. That'll probably help, because I'm definitely getting weirded out by the angles involved here. Actually, yeah, probably free body diagrams are going to be like helpful as well. Let's start with that. So the M block is being pulled down by gravity. It's being pushed. Well, ooh, no. We shouldn't be so. The downward force is mg sine theta. It's being pushed to the left by mg cosine theta. To the right, there's a normal force by a wall. And then I guess upwards, we should say there's a normal force from the... I don't know if this is a good idea or not, but there's a normal force from the wedge, I guess. Twisting, I was studying organic chemistry and asked ChatGPT for the lab preparation, and I doubt it's accurate. You don't know the textbook. Yeah, I think you're being a little too like paranoid there, Seth. Okay, so the block of mass m, small m. What is this thing's free body diagram? I mean, it's gonna have its own gravitational force, but it's also being pushed on by the block. And so the only force from the capital M block that's relevant to the small m wedge is mg sine theta, right? And so I think we would call that as a normal force by the time we get down to the wedge here. There's a directly upward force from the normal force of the table. Yeah. But this big mg sine theta, I think is going to get... It's going to be broken up into... This is kind of funny, because we've taken the capital M block's force due to gravity and split it up into... Oops, I just undid too many things. I don't know what other thing I undid. Oh well, must not have been important. Like, we split the big M block's gravity up into two components, and I think we're going to take the down component and split it up into two more components that are in terms of this wedge here. That's what it feels like we're doing. But how, like, My LE, oh, I did, yeah, thank you. We need some sort of force to the right here, and that's what I'm trying to think about. It's some force from this capital M block, and I'm trying to... Oh, you know what? Maybe I'm thinking... Am I thinking about this wrong? I'm wondering if these vectors are actually oriented like this. Maybe the mg cosine theta is right. Torque is 0, one more equation. We haven't gotten to torque in this part of the textbook yet. So I don't imagine we're going to need torque here. I don't know if this is right, but I'm wondering if the mg sine theta is actually oriented perpendicular to that bottom surface. Does that make sense or no? Indian Scouser seems to agree with that idea. If the wedge is moving to the right, there should be a greater force on the left side of it than the right side. More of the weight is distributed in the left side of the block. Yeah, I think I can see that. We're like, in the starting configuration they have in the figure. Well, I know it's not so like the left side of the block, but it's kind of like, I don't know how to describe this, to be honest. I think I know what you're getting at, but like, the thing I definitely expect to happen is for this wedge to move to the right. And so that means there is something weighing it down on the left there. I'm kind of warming up to the idea that that vector is pointing perpendicular to the diagonal piece there. And so it would mean that we have, when we come over to the wedge, let me do a different color. We have a force acting on the wedge that's like that we want to split up into components again. And so this FNM that I wrote is going to be one piece of that component. I feel like I need to make a second triangle here. Because we have a right angle there, an angle theta here. PhD in memes and brain rot rather than this stuff. I guess you're welcome to that, Twisted Memes. MG is in minus j hat directional. MG sign is perpendicular to hypotenuse. Okay. If we have a vector there and we want to split it up into a component that is parallel to that side and parallel to that side, how do we accomplish that? I wonder if I'm... Let me, I want to make that a green. So you know what? Maybe I don't like this. Maybe you just have a vector of length mg sine theta. That's perpendicular, but we could also slide the bottom wedge of the triangle up here, and that's going to make an angle theta. So this is going to be pi over 2 minus theta. Okay, nice. So we want a component that's like that and a component that's like that, I think. And so the component, I should make more use of colors. We'll have a light blue component and a red component. I think it means the red component is going to be mg sine theta sine pi over 2 minus theta, which is probably cosine of just theta, but I'm going to leave that as is for a minute. Sine theta, and that's going to be cosine pi over 2 minus theta. And then what are our cofunction identities? Do those match how I think they match? Yeah, sine pi over 2 minus theta is cosine, and cosine becomes sine. Okay. So this is really, that's a terrible place to write it. Mg, that becomes sine squared theta. And then the other one becomes mg sine theta cosine theta. Which you could write as, we could rewrite that using a half angle. I don't think there's a point in doing that though. We're gonna find acceleration in terms of theta, Seth, and that's okay. Joseph is the master of these types of problems. Oh, really, Ren? I believe it. So I think what I've concluded here is that mg sine theta cosine, sine squared theta is the force acting to the right, and the force acting straight down that's equal to that normal force that I wrote is going to be the red one. You gonna deal with all this next year? Good luck, twist memes. I'm not the biggest fan of mechanics. I'm studying it because I think it's good to know, but it's kind of a pain. So vertically, like, I think it's safe enough to assume that there's no vertical acceleration. I definitely hope there isn't. So I think we only need to worry about horizontal forces, and we only have the one horizontal force, that's mg sine squared theta. So if we use the F equals ma statement for the small m block, we know that the mass small m times whatever acceleration is a should be equal to big M g sine squared theta. And so if we want to solve for acceleration, we just divide out small m. Okay, so this is my tentative answer, but let's kind of think about the extreme cases here and see if this matches up with intuition. Mechanics never fixed my car correctly. Imagine if theta is 0, would an mg sine be 0? If theta is 0, we get 0 acceleration, and that kind of makes sense, I think. I expect more acceleration the steeper that angle is, right? So it should drop off to 0 the shallower the angle is, I think. And so I think this sine squared theta dependence, it checks out. Like, I can't quite verify the squared part, but theta seems to behave as I would hope. If big M is very large, then the acceleration does increase, and that makes sense. If small m is very large, the acceleration decreases, which I think makes sense too. It would hardly move if the triangular wedge was massive and the big M wedge was tiny. And then if we lived on a planet with really high gravity, this entire thing should happen faster. So I think our extreme cases check out. Normally in this book, we just leave gravity as a letter. Oh wait, do the units? Yeah, the units check out. I guess let's check the answer here. Number 16. Oh, they're doing... maybe not. Oh, what's their final answer? They did a completely different way. What? I'm completely wrong. Okay. Well, that's cool. I don't quite get what I did wrong, but let's see how they set it up and then see if we can follow it through. Let n be the normal force between the block and the wedge. The vertical F equals ma equation. I assume I must have gone wrong with thinking that mg sine theta force was perpendicular to the surface of the block, maybe. I don't know what else it would be. Let n be the normal force between the block and the wedge. They don't actually drop, but okay. The vertical F equals ma equation for the block with downward taken to be positive. Oh man, this normal force is almost acting like a tension in one of those Atwood's problems. Where you don't really worry about what it is exactly. Huh. Is n a reciprocal of m? No, m is the mass of the big block. And n is the normal force between the big block and the triangle wedge. How do they get to this tangent relationship here? So there's this relationship between the movement of the triangle wedge in the x direction and the movement of the block in the y direction. You take two time derivatives? Oh my god, okay. Alright, let's go back to the drawing board here. Dude, I felt kind of good about this approach. Evidently it's all wrong. Okay, so we don't even care about the pi over 2 minus theta piece. So they didn't. I wish they drew it because I'm a little bit weirded out, but I think the normal force is like that. And they took a vertical component and a horizontal component of it. And how does this work again? I'm not... Okay, let me... N. And then we want vectors like that. For reason, this geometry is always really weird in my head. I think... Oh yeah, we can say that angle on the bottom is theta. And that's the trick that we need. Which means this angle on the top is also theta. So then the piece coming out here is n sine theta. And the downward piece is n cosine theta. I'm going to verify that against the answer key, but I want to puzzle it out for myself first. So I think they did the exception of the capital M block first. And they took downward to be positive. So it has a force down due to gravity minus the upward normal force, which is n cosine theta, because it should match. Or, yeah, I mean, I that probably is not quite accurate to put those forces exactly where they are, but it should be like the same like magnitude, I think. And that would make, oops, the exertion of the wedge only thinking about horizontal and sine theta. So let me check the answer key and see if that matches. mg minus n cosine theta is equal to big M a sub big M. Oh yeah, okay, yeah, different a's. And then small m a sub small m is equal to n sine theta. Okay, good. We got our first two equations matching. Now comes the weird argument where you imagine, basically, we want to solve for these a's, but the n is also an unknown. So we have three unknowns in only two equations, so we need a third equation. And that one comes from how the displacements of the two blocks are related to each other. Yeah, Depian. So if the wedge moves a distance to the right x, the capital M block also moves a distance y. And I'm drawing it up just because it's going to make the geometry a little bit easier to think about it. That's the same angle theta. That looks like x is the angle, but it's supposed to be the side length. And so if you're given a displacement x that's equal to y, or rather tan theta equals y over x. And the calculus is a lot easier to do if you make it x tan theta equals y. And then x and y are both functions of time, so you can take two time derivatives of this thing to find a sub, well, let's just be clear, x sub small m, y sub big M. There we go. So now that's the equation's three unknowns. Hey Phobos, how's it going? Your Final Fantasy went well. It's good. Glad to hear it. So let's take this equation and plug in for the a sub big M up there. So we get m a sub small m tan theta equals mg minus n cosine theta. Then the second equation will transfer down as it is. I wouldn't change a thing about it. And sine theta. So now I'm gonna take the second equation and isolate n, maybe. I just kind of want to get rid of n. We don't care what n actually is. So we know that n is equal to m a sub m sine theta. And then we'll plug it in up there and hopefully get something good. Trendy Ruba and JE, we drink these questions. I completely believe you, Dipion. JE questions are kind of insane. Needlessly so, I think. Cosine over sine, that's cotangent, isn't it? N a sub small m cotangent theta. Oh wait, no, we got rid of the capital N. Ugh. The ones I've looked at are just annoying, to be honest. For JEE problems, they're just all trick questions, and you have to learn the tricks. That's why I don't really. I usually don't really enjoy them. So we want to add the a sub m's together and factor them out. So if I add that chunk over, like I think I could learn JE and figure out how to do the problems pretty consistently, but it's just, I don't know, I don't really see the point if I don't think they're fun. Shouldn't the phrase H0, 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 H0 just simplify to 0? Is Santa stupid? True. It's a very good point, Syntax. Okay, so this is nearly... I think this is equivalent to the answer the book gets. We probably I need to do some trig to make it match exactly. H sub 0 to the 4th, true, too. How do you deal? We probably want to multiply everything through by tangent. Like tangent over tangent. Where do I do this? Because I'm out of room on this page. We're gonna do a little squiggle arrow. Come over here. If I take the cosine out of tangent and multiply it through the bottom, what does that look like? And then we multiply it by cosine over cosine. And I think that matches the book. I don't remember how the book's answer looks. This feels about right, though. And okay. Oh, yeah, okay, so let's think about the limiting cases before we look at the books. Dude, how do you... Okay. For large values of theta... That's annoying. And by large, I mean, for as theta approaches 90 degrees, we get approaching 0, approaching... No. Approaching 1, approaching 0. So the overall thing should be going to 0. Which makes sense. If it was 0 exactly, then there wouldn't be any movement. If we... Wait. No. I was saying for theta approaches 90, we get very little acceleration. Maybe that makes sense too. Or do we have a sweet spot at like 45 degrees? Yeah, maybe like if you have a really steep angle, there's just not that much vertical displacement you can do. I wonder if that's it. That's why you don't have, that's why it gets very small. Because for theta equals 0, what happens? That goes to 0, that goes to 1. So the overall thing goes to 0, which that is a lot easier to think about. That's making sense. So yeah, I think there is a sweet spot, probably around 45 degrees, because you could read that as like 1/2 sine 2 theta, and that's gonna have a maximum at 45 degrees. I'm kind of ignoring the denominator with this argument, to be honest, but if big M becomes very large, this one might be an interesting one to... Okay, let's get a new page. If big M becomes very large, I think we could basically say it's equivalent to this situation, which would simplify to cosine theta over sine theta, g cotangent theta. I don't know what that's supposed to be. Does that make sense? It will blow up because cotangent... No, how does cotangent look? Cotangent is this one, isn't it? Yeah. That doesn't make sense, does it? For an angle less than 45 degrees, it's going upward? $35 plus 315? 350? This limit doesn't feel quite right to me. If it was tangent, I think I would feel better about it. Would I? I think so. No, there'd be an asymptote if it was tangent. No, there wouldn't. I don't know. You think it's negative of that? I don't see where it would come from. You know what? Oh, wait. I think I'm thinking about this wrong. If the horizontal axis is t, then this asymptote is c equals pi. We only think about this section of the graph. So this actually, that means there's no sign change on that portion of the graph, and that's okay. Or that's good. There shouldn't be a sign change. I always get messed up with the asymptotes for tangent versus cotangent. And I shouldn't draw that other dotted line like it's an asymptote. I should say that point right there is like at t equals pi over 2. And so we only really worry about that portion of the graph because we're kind of taking theta to be between 0 and pi over 2. Doesn't mean for theta is 0, it's a very big acceleration though, which that still doesn't track. Like asymptotically, or infinitely big. So I'm not a fan of that still. So I'm going to ignore the m and m in the denominator and simplify the sine squared and cosine squared. I don't think so, PhD. It feels wrong to, I want to use a Pythagorean identity there, but I don't think we can. Not a way that I see, at least. It's kind of annoying me how cramped I wrote that. Let me rewrite it down here. Rewriting that could be helpful is making it 1/2 mg sine 2 theta. I was using that to think about the theta limits before, but it's good to actually write it out here. Let m equals m. I mean, we can do that too. I'm kind of tripped out by big M approaching infinity. Maybe it's not supposed to make sense. I don't know. Maybe I'm checking the wrong limiting case. All right, well, if we let the m's equal each other. Oh, hey, that's where you get Peach T's thing. Idea. So you can factor the big M out from the bottom, cancel it. You get g sine theta cosine theta. Just over 1, I guess. So you get just that. Oh yeah, that was a drawing routine that Thunderfix made me do. So I drew that one myself. I'm quite the artist. If the masses are equal, you just get 1/2 g sine 2 theta. Which, I mean, that kind of seems to track. I don't know. Like, just getting the numerator more or less feels good to me. The answer I got is definitely right, Seth. It matches the answer key. Just with physics problems, it's always good to kind of check limiting cases and see how it behaves. So I'm just doing that kind of for like learning sake. The big M going to infinity just doesn't really make sense. And I can't tell if it's not supposed to make sense or if I'm doing it wrong. If small m goes to infinity, I think we can simply say that the acceleration is going to 0 because the denominator is getting massive. And that makes sense. And then theta I kind of talked about verbally. So maybe look at the books. Limiting cases here now. So we do have a sweet spot where theta about 45 degrees is probably what you want for a maximum. If the big block, okay, yes, that's the last case that I checked. Now this is the case where I'm really interested in. Oh. Use multiply, oh, okay. The block is essentially in free fall. Okay, that makes sense when they put it like that, I guess. Oh, thank you, Demean guy. I appreciate that. And Meowhib? Am I saying that right? Thank you for the follow. Yes, it is awesome. 25. Hey, Jed. Since the constraining force on the left side of the block equals n sine theta, which in turn equals MAM. Okay. Oh, really, Joseph? This is from Morin's Blue Book. Oh, thank you, Malhib. Meowhib. If you're new to the Twitch math community, whenever I see a new face, I do like to shout out that I'm not the only one out there who does this. So if you're into math streams in general, there's a whole bunch of people who do math help in some way. I think I'm just gonna keep on doing this, Seth. Thank you, though. To Morin, that's why it's in our midterms. Yeah. It's a really nice book, but you have to be able to keep your spirits up as you get your ass kicked by its problems. That's what I found, anyway. Up and down a plane. A block with mass n is projected up along the surface of a plane inclined at angle theta. The initial speed is v naught. The equation of both static and kinetic friction equal to 1. The block reaches the highest point and then slides back down to the starting point. Oh! So in order for the block to in fact slide back down instead of remaining at the highest point, theta must be greater than 45 degrees. Okay, this feels kind of fun. Famous last words. Okay, so here's our inclined plane. And so we have a block that's just given an initial velocity. We have to look at how that thing is going to behave. Hey, Famished. The other exercise for math, deal with Don does games too. Yeah, I mean, weren't you here yesterday when I was playing DayZ? But it's actually the name of, I have a gaming YouTube channel. It's kind of suffering from neglect, but it's called Don Does Math and Games. So I kind of have that. And it's like the whole like DDG logo too, so. So let's think about the block's acceleration. That feels like a good start. So, and we have to do that from F equals ma. So this is kind of weird. We have The friction is mu k f sub n, but the direction of this is going to change, which potentially change depending on theta, which I'm not quite sure how we're going to deal with that. Pulling it always to the left, we do have gravity times sine theta. I think they're doing us a kindness with saying static and kinetic friction are the same value. I think the problem would be a little bit harder if they were different. I'm still kind of worrying about, like, eventually this thing's sign is going to flip in certain cases, and we need to account for that. So probably a trig function will take care of us there, right? Well, yeah. Maybe. And if we're gonna have a breakpoint at theta equals 45 degrees, we probably are gonna expect a sine theta cosine theta being involved here. Because just sine or just cosine. I mean, no, you could have like a tangent. No, you could have a cotangent. That would do the trick too. It might actually be a cotangent the more I think about it, because that actually has a sign change at 45 degrees. Sine theta cosine theta does not have a sign change. The normal force is mu sub k is 1, just like mu sub f, so we don't have to worry about what one to use at what point. I think the normal force is mg cosine theta, isn't it? Well, I guess the cosine minus sine might behave how we want too. So if we, like, let's divide out m, factor the g out. Does this thing do what we want? Should we actually look at velocity, not acceleration? Let's just first get a handle on what cosine theta minus sine theta does before I get too crazy. So at theta equals 0, we have 1. Let's make it a little bit higher. We can make our scale bigger here. At pi over 2, negative 1. That seems good. Because then they're going to be connected like that. That means there's a 0 somewhere in there we don't have to care about. Actually, we do have to care about it, don't we? If we want to show that the block is going to slide back down, do we want to integrate our equation for acceleration to get to velocity, or can we just use the acceleration directly to say that? The acceleration is constant. I think we do need to think about the acceleration for the case where it just stays still. So what would this thing look like if it just stuck at the top? So should we find where this thing is 0? It probably is 45 degrees. Let's prove that. Cosine theta equals sine theta, and yeah, that's just 45 degrees. So if 0 is less than theta, well, we can say we're equal to, it doesn't matter. Acceleration is positive. That doesn't really make sense though, does it? How is it accelerating positively? I think I messed up a sign or something, didn't I? I think acceleration shouldn't have a sign change. It should always be negative. It just is going to get small enough. It should just be small for 0 to 45 degrees, and then big for 45 to 90 degrees. Maybe that's what we want. So I think maybe I'll just slam a minus sign in front of here, which means a minus sign gets slammed there, which means a minus sign, we can factor the minus sign out. And how does this thing behave? Sine theta plus, or cosine theta plus sine theta. I want the minus signs in there. It's gonna be too weird to track it otherwise. Okay, so at theta equals 0, we get -1. At theta equals pi over 2, no, we should plug in theta equals pi over 4. No, let's, what do we want to do? At pi over 2, I think we're back at -1, aren't we? That's weird. I don't like that. We're getting something like that, aren't we? That can't be right. What I want is behavior, something vaguely like that, where it's monotonically decreasing. That's the important thing that I want. And like theoretically, there should be a breakpoint somewhere halfway through where the acceleration is enough to overcome the friction. So I think I'm still wrong, is the moral of the story, which shouldn't come as a surprise. How can we be right? Oh my god. Sorry, I forgot to unmute myself. I'm getting distracted by my lighting again. On? Off. On? That seems like a lot better, right? Oh my god, I shouldn't be doing this right now. Okay. So bright I am now, and then if I turn it off, is this actually making a difference? Yeah. And the camera kind of adjusts. The camera's doing some work, but now I'm not so shiny. Okay. I think this is an improvement. um oh, I hope. Anyway, am I thinking about this wrong? No. I mean, well, I am, but I hmm. You might understand what Lagrange is on about. How so? Oops. Veritasing a bit about action. I don't know what action is. The normal force should vary with time, shouldn't it? Well, no. No. The friction... No. That was just an incorrect statement. Integral distance times speed times time over one of these variables. What the hell? That seems like some weird analog for work. I can't quite figure it out though. Hey, Central. Bored later? Yeah, I'll pull it up. I'm not gonna like watch it right now, but oh, the brachistochrome curve. Okay. So that's why I haven't heard of it. It's like some calculus of variation stuff. So yeah, that I'm not surprised that I don't know. I haven't heard of action. Um, 200 in 1600s call it. Oh, okay. What the hell's with this problem, man? Why? I feel like this has to be wrong, but I don't see how. What if... Okay, you know what? Let's actually go with this form. Let's just integrate it with respect to time and see what happens. Okay, so... Business said these types of equations can be solved by finding a solution when differential of action is 0. Hey, oh god, Matt Yenge or Maddie Yenge or I'm gonna struggle with that name, but welcome in. And I was wondering about that. I don't know is the answer. It feels like the velocity. Something does feel off about my normal force. Like I feel like there should be some dependence on the velocity here, but like I feel like I just don't see where it actually works in naturally. Um, yeah, this is just a completely wrong bit behavior for the theta part. The block is being affected by the upward force of the surface at the incline, right? Yeah, so um the incline is putting a normal force onto the block. That's like what's holding it up. A non-conservative force come into play, and here we have friction. Hmm. Hey, air engineer, is work being done on the crate? Uh, I don't think so. Well, I guess if no, maybe negative work. I think yeah, I'm working on part A still, aren't you? The only forces that are acting here are gravity and friction. When the block is still moving up the incline, friction is going the wrong way to do work, right? And when the block is moving the right, when the velocity is going down, it's sliding back down, friction is going upwards, but the block is still moving down. So that's why I said maybe negative work, but this part of the textbook hasn't gotten to work anyway yet. Um, Trying to find the value of the hypotenuse. I mean, the hypotenuse is just an infinite plane. Like, for the sake of the problem, it just goes on forever, I think. Does this seriously go exactly back to its starting point? That's gonna be kind of amazing if we find that. I wanted it to go to the starting point. I feel like it would go shorter. But I guess if we get this problem right, we can figure that out. um, I should maybe check my trig functions. Like, is that actually cosine theta? Is that actually sine theta? Because that could be a pretty basic mistake that I'm pretty likely to make. It is a pretty common mistake for me. So triangle theta like that. We have a normal perpendicular vector like that. That angle is theta. That angle is theta. Oh, wait. I might have mixed them up. Because actually, I should be drawing it more like a... MG is going down like that. We want a component perpendicular and a component parallel. That's what I should be having. And so maybe like that is a easier thing to draw because that's clearly theta. Wait. Yeah. That's theta. And so the angle up here is pi over 2 minus theta. And so parallel to the plane is cosine pi over 2 minus theta, which is sine. Perpendicular. Oh my god. Let me catch up with chat. Set A equals 0. I think A sign is wrong. Yeah, that was the first version that I had of that problem, having it be positive cosine. I still got to something weird though afterwards, so I tried having both negatives. I didn't quick math and tell you to solve it. You have to solve it quick, right? 200 IQ. There you go. That's the secret. Mg cosine theta, I guess. When theta equals 0, the gravity should be max. Yeah. And that would be, yeah, okay, that's like a nice intuitive way of thinking about it too. Was I just coming to that conclusion too? Let me check the work that I was doing here. Parallel. Wait, I'm not drawing this right. Still. You want a vector parallel and a... Okay, I need to exaggerate this arrow a little bit. That's the triangle that we want. This angle right here is theta. And so this thing for gravity's component parallel to the plane. Oh, that's sine theta? That shouldn't be right. Ugh. I hate this. Okay, so I feel like this should be cosine theta because what I like what Aero Engineer said that theta equals 0 should give us the maximum gravity, but I can't actually justify that with this triangle. Actually, the book did this explicitly, didn't it? It would have been, I think, in chapter 3. Acceleration down the plane is g sine theta. Really? Oh, no, yeah, so we should have a sine theta because the force due to gravity is at its least when theta, or sorry, no, no. This should be the simplest part of the problem, and I'm getting tripped up on it. Condition to find theta is a equals 0, a along incline. Yeah. The acceleration along the incline is g sine theta. Acceleration so I have switched. Wait. No, I haven't switched them. Okay, yeah, the acceleration along the incline is g sine theta. So it's being pulled that way with mg sine theta. I can't explain that away, that intuition thing, but the and then the normal force, it is going to be the cosine theta piece. Now, the sine may be all sorts of messed up. Because what gets me is that if our initial velocity is going up the incline, then the friction is going that way in the same direction as gravity. But if it does turn around, it's going to need to, turn around at some point. And that's how I don't know if we're supposed to capture it here or not. But that's why, at least in that initial condition, maybe we... Alright, you know what? Fuck it. Let's just go down this road again. I already forgot what didn't make sense to me when I went down this road. So let's just make the same mistake twice. So how does cosine minus sine behave again? Oh yeah, the thing I didn't like about this is that when theta equals 0, you get positive 1. And then when theta equals pi over 2, you get negative 1. In the acceleration, changing signs seems really weird to me. That's what I didn't like about this. Let's make Desmos verify that for us. Yeah. Oh wait, 3 pi over 4. Wait. What is it? Yeah, pi over 2. So it does fit that condition that theta equals 45 degrees gives you 0. But if theta is less than 45, it seems like the block is moving up the plane magically. Or like it's being accelerated up the plane magically. And that's what I don't like. It can never be accelerating upward up the plane because there's no forces pushing it. I mean, there's friction, but friction is never going to reverse the direction of something and start like, well, wait. It can reverse the direction of something, but it's not gonna... What the fuck? Yeah, like what I'm reading from this equation is that if you have a shallow angle, it's not shallow enough. My equation is saying that the block is accelerating up the plane, and that just makes no sense to me. The friction, if the block's velocity is to the left, then yeah, sure, friction is pulling it to the right, but it shouldn't be accelerating. Well, it would be accelerating to the right. So maybe this actually does make sense, where maybe... Well, it stops you from falling, but it's not going to like I'm saying like the block has a net acceleration up the plane, which just like this way like the net acceleration being up the plane can't happen. The friction individually can theoretically pull it up the plane, but it's never going to, or like it can only ever slow the fall. It can never. What's the word? What a. Dude. It's annoying. So I don't. Should I call you Matt or Maddie or Matt? I'm not sure. I mean, I'll just say Matt unless you could correct me, or Maddie maybe. My intention is that this equation right here is only, I guess you could call the x direction. It's only the direction parallel to the plane. I may not have captured that correctly, or almost. I feel like I haven't, but this should be the acceleration parallel to the plane. Is that the key? Should I be thinking about the acceleration perpendicular to the plane also? No. It's going to be 0 perpendicular to the plane. There might be a helpful fact from there. Maddie Eng? Okay. Thank you for for letting me know. UF doesn't know the direction of motion. I mean, it opposes the direction of motion, though. Okay, I mean, just so I could say I've done it, if I integrate this thing for time, what does that look like now? Like, could that behave how I would want it to behave? Like, maybe this is easier to think about. And maybe Desmos will think about it for us. I'll just say like 10 minus 9.8. I mean, I don't know why I'm plugging in all these actual values for stuff. Let's do pi over 3, more than 45 degrees. We want to line with the opposite slope, right? Yeah, that's more than 45 degrees. So have I maybe chosen poor initial conditions? No, I mean that's the y-intercept. Oh, thank you for the follow, Maddie Inch. I'll see you around. Just a little like quick thing. I hope I didn't already. No, I didn't. I'm not the only math streamers out there. So if you're interested in other like math streams, I know I'm studying physics right now, but the main thing is usually math. I'm not the only one out there who does it. So if you're ever interested in looking for more people, there's a whole list of them. Wait, why does this have a positive slope? Oh, because theta is... Something's amiss here. GCG. Help me understand how to use CPCTC in triangle? I have no idea what the hell that is. CPCTC triangle. Q math is good. Corresponding parts of... What? Go away. Corresponding parts of congruent triangles are congruent. Yeah, I mean, I don't know. Is there a specific proof that you maybe need help with? This website is kind of showing. So I don't know by this name, but this is something that's pretty common to use. Basically, if you know the two triangles are congruent, they can say you can say that each piece of them is also congruent. So let me just. Maybe I shouldn't draw a right triangle. Those are too nice. If you have a triangle like that, angle 1, angle 2, angle 3, and we have a triangle that's congruent, meaning it's literally like a copy paste, so I'll just copy paste it. We can say that if we know that the entire triangles are congruent, say A, B, C, D, E, F, if we're given the fact that triangle ABC, is that congruent? I think it is congruent to DEF, then we can also say that every piece of these triangles are also the same. So this statement implies that angle A is equal to angle D, because these two are corresponding angles. So you can say that all the angles, as long as you match them up correctly, are equal to each other as well. You can even write like if, then all of these statements that we're about to say are going to be true as well. So angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. And so those are the angles. We can say those are the same, but we can also say all the sides are the same. So the side between A and B is the same as the side between D and D, because those are corresponding. So we can say the line segment AB is equal to line segment DE. You might have like... The notation for that can vary. You might have like vertical bars there too, or you might remove the bars on top entirely, just as a warning. So if you see it with slightly different notation, then I wouldn't worry about it. but you can say that the lengths of the sides are the same. That's what this really means. Similarly, BC is equal to EF. And then AC is the same as DF. And so they can trick you when you see an actual proof, though, where they can give you a weird situation that looks like a bow tie, basically. And you have to, like, what's corresponding to what isn't as clear as this nice situation I drew up here. So let's say we have A, B, C, D, E. I guess we're going to do math again soon. Been too long. You do whatever you want, Phobos. Now they have to give you some information for you to know that it's congruent, or they need to tell you that if you somehow magically know that triangle ABC is congruent to CDE, which this picture alone doesn't tell us, but if we just know that, you know, on the side, then we need to figure out what's corresponding here. And I think the easiest way to do that is to just make a separate picture with the two triangles separated. So we know that, hopefully you've seen this in geometry before, but anytime you have two lines kind of like intersecting in an X, I think, what is it called? I forget the name of the theorem, but like the top and bottom angles are the same and the side to side angles are the same. So we know that this angle is equal to that angle. And so from here, we know that these two angles should be corresponding to each other when we think about the congruence. So I'm going to draw two separate triangles, and I'm going to put this, like, these angles on top and let the rest of the triangles like fall where they may. So I've taken this triangle on the left and I rotate it around like that direction. So C is at the top now. A is down here. B is over here. Vertical angle theorem? Yeah, it might have that name. I feel like I learned it with a different name, but that's also like an accurate sounding name. Now this triangle over here, in order to get C at the top, and I'm just kind of choosing C to be at the top, we're going to take that triangle and rotate it around that way. So then C is at the top, D comes down here, E comes down here, and we know that C's are the same. Hey Kuzaima, it's been a minute. Oh shoot, is it pronounced? You told me I was pronounced, and it's been too long for me now. I hope you're doing well. And so now from here, now that we have this picture on the bottom, to me, it's a lot easier to tell what's corresponding to what. Because now we can just match them up like positionally. Like the bottom left, B, is equal to the bottom left, E. The bottom right, A, angle is equal to the bottom right angle, T. And same with the sides. So that's kind of, I'm not good at visualizing this, so I have to draw it out like this usually. But that's how I kind of think about pairing up sides when triangles are congruent. I feel like it's Guhaima, but I'm sorry if I'm mispronouncing your name. The question was from GCG there in the YouTube chat, which is how to use CPCTC in triangle proofs. And that acronym was a new one for me. But CPCC, I can't say it. Its corresponding parts of congruent triangles are congruent. So I was explaining how to match up corresponding angles and sides for triangles that you know are congruent. And so GCG, let me know if you have any questions about that, but I think that's everything that I can think of to say. it does definitely get tricky once you start having to rotate the triangles, because they can also like reflect them, or like, you know, the triangles we have are kind of like mirrored, so you have to like untangle that a little bit. But well, they weren't actually mirrored, I guess that's a bad word to use, but they can do some weird stuff with mixing the triangles up, so you have to be careful about what actually goes with what. Okay, so the question I was working on before this was this physics question. Oh, and I'm struggling with it. Hey Mateo, do I do linear algebra and calculus exercises? Calculus, definitely yes. Linear algebra, um, my linear algebra is pretty weak, but depending on the question, I can answer it. Right now, I've been interested in like just in my spare time, I'm just doing physics problems for fun. But I've had phases where I do. I generally just go through phases where if no one has a question in chat, then I do whatever subject I've been finding fun. And right now, it's been physics. But if you have a question about either, feel free to let me know, and I'll do my best to answer it. So for the case where theta is greater, ooh. So what I was hoping for is that if theta is greater than 45, what I wanted to get is like a y-intercept v naught right here, and then a negative slope that goes like that. Because this would reflect going up the plane, stopping, and then going back down the plane. The issue is it's not going to go out forever. It's going to stop again. So do we actually expect a behavior like that? How would we possibly get that, though? I think we would we would need to like I'm coming back to the normal force, and I feel like there should be. The color cone. Thank you for the follow. The only way we could maybe get this behavior is if the normal force has some dependence on time. Shouldn't. Why is it friction dependent on velocity? Like, it should be, right? It just feels wrong to not have friction be dependent on velocity. Hey, Mateo, that's you. Join the Discord. Just let me know if you post a problem in the Discord, otherwise I might not see it quickly. But if you do post a problem, I'll switch right over and think about that instead. Friction force. The friction force is independent of contact area and relative speed? I think it's even just my differential equations brain. So I feel like in differential equations, you would say that it's proportional to velocity. I wonder if we have to do this with a piecewise equation. What about that? I don't quite know how to define that for equal to 0, to be fair. There is no friction. Well, there was definitely still gravity. Dude, I don't freaking know. I'm gonna look at the first part of the answer. I feel like I've been suffering with this for long enough. Hmm. Okay, so they skip straight to thinking about the highest point of the block. Which I feel like I was trying to show that the highest point exists in the first place. And maybe I was doing more work than I needed to. Oops. In order for the block to slide back down, FG is greater than FS, which implies MG sine theta is greater than MG cosine theta. Which implies tan theta greater than 1, which implies theta greater than pi over 4. Okay, and I think that's all you really need to say for part A, I guess. Oh, you think the stream is frozen? Yeah. These problems are kind of brutal. They really make me think. Okay, so that's I think all we need to say for part A. I like usual, I'm making it too hard on myself. For part B, find the times of the up and down motions. Now this feels like we do need to know this might be okay though. I wonder if this is what Orangey was saying all along. Because now we're given that theta is greater than 45 degrees, and so I wonder if we don't need to worry about piecewise functions now. Because we've kind of narrowed down the situation that we're in. So that's our acceleration for theta greater than 45 degrees. I think this is going to be the entire story for the acceleration. I think it's the story for the acceleration on the way up. And since theta is more than 45 degrees, this is negative. And there's a negative sign out front as well. So I think it's going to be a positive slope line. And I think that's a good thing. We're concerned with the time of the up and down motions. So we want to set this thing equal to 0, because that's when it's going to reach the peak. Oh wait, no, that's not good. It doesn't, it reaches 0 at a negative time. That's not good. Because this line looks something like that. And V naught is right there. So do we need to integrate again to get to position? Okay, I think we can either integrate again to get to position, or we can think about the velocity on the way down as well and figure out where the two lines intersect. I kind of want to try it both ways and see if it matches. So let's start with on the way down. Wait. That doesn't make sense. I was just going to take the same equation last time and put a negative sign in front of here, but that's not right. Shouldn't this already have a negative sign in front? And then on the way down, I would get rid of the negative? The velocity should be going down. Oh my god. Is that okay? Yeah, I think we do need a line that's like that. I think we want that because both the friction and the gravity are pulling it down the block. Um, Wait, does that agree with what I entered into Desmos? It does. So maybe the graph that we're going to end up with in total is like a piecewise graph where we're going to have a line, a linear function here for velocity. And then we're going to have a parabola because it does have to get to the top, stop, start accelerating downward, but then stop again where it initially went. So I feel like it has to look something vaguely like that. But wait, what happens if we set if we find where that hits the t-axis there? Does that check out dimensionally? Yeah, that's time. In theory, that's the answer. I'm not sending it yet, though. Oh, wait. Oh, the times of the up and down motions are... that's not the same time. Those are different times. I was just reading part C. Um, that's time for the upward motion, I think. So maybe let's think about the downward motion. Oops. Ugh. So on the way down, we're going to have MA is equal to... Now friction is pulling it up. And gravity is still pulling down. And we'll have a different initial condition as well. And then... we're integrating. Now, if theta is greater than 45 degrees, right at 45 degrees, this thing is 0. Which is consistent with the block just stopping, I think. If it's greater than 45 degrees, let's try 60 degrees. You would have 1/2 minus root 3 over 2, which is a negative number, which is good. That should be good because it should be negative velocity. No. Wait. It needs to climb back up to 0. How does that work? Oh, no. God damn it. How is it stopping a second time? Like, so right now I'm confused on this sentence here. If the block is, if it's at such an angle, that the block comes up, stops, and then goes back down to its starting point, surely it would keep on going past its starting point. It wouldn't just randomly stop again. Now, do we only care? Like, are they not saying that it stops there? We just only care about, like, the time interval. I, okay. It must be that we only care about the block once it passes by its starting point, but it's going to have a velocity still and keep on going. Like, it's gaining speed as it goes back down. Because I don't know how else this problem physically makes sense. Hey, Simply Facts. If I set this upright, which is a big if, can you explain the difference between permutations and combinations with examples? Yeah, so need it for your A levels? So let me be careful with what I'm going to say. I'm going to refer to a website here just because I don't want to say the wrong thing here. I want to see an example of a combination. Okay, I like these examples more. Okay, I'm glad it is because I these are better examples to use than the one that immediately came to mind. So a combination it answers the question. I should type this. That'll be much quicker than writing it. They answer the question, how many ways are there to choose k things out of n total if order doesn't matter? An example of that is I like the website's example of a dessert menu has 10 items on it. How many different ways can you order 3 desserts? So an example, and so to break that down even further is, let's say the menu has 10 things, maybe a little bit big. Let's just say 5, just to make me not have to think of 10 desserts. Cake, pie. I'm already running low. Ice cream. Cookies. Cake, pie, ice cream, cookies. I'm missing like something obvious. Cake, pie, ice cream, cookies. Brownies. Yeah, good one, Jed. An example of one way to order 3 things is you can choose one combination: pie, cookies, and brownies. Combination of 3. Creme brulee, cheesecake, fresh berries. Okay. I get it. You're good at naming desserts. So one combination of 3 is pie, cookies, and brownies. You could order cake, ice cream, cookies, and you're basically going through this list of 5 things and getting every possible combination of 3 items. And that's what combination gives you. So I won't go through and get literally every single combination of 3, but I hope that conveys the idea. Permutations they answered the same question, but order does matter. Sorbet, parfait. I never had parfait. Churros, dulce de leche. An example of this is like that's not best example necessarily. No, okay. I'll use the example. How many passcodes exist for your phone? So, like a passcode for your phone, I'm just gonna, do a simple example where it's like 4 digits. Has 4 digits. And just to make this simple, we're gonna say you can't repeat a digit for now. That means your passcode could be 0, 1, 2, 3. It could be 4, 8, 7, 2. Oh, wait. Yeah, okay. So it could be 0, 1, 2, 3, 4, 8, 7, 2, whatever. It doesn't matter. The important thing here is that we are also going to count, let's say 8472. The same exact digits as the one right before it, but we switched the 8 and the 4. These are two different things for the number we get from a permutation. Whereas in combination, ordering pie, cookies, and brownies would be the exact same thing as ordering brownies, cookies, and pie. Like, this other ordering does not get counted in a combination. That's the essential difference. Because if you're at a restaurant, you're getting all 3 anyway. You don't care what order you're handed the plates in. Yeah. Okay. Awesome. I'm glad that I get what you mean, but let's see. Please look at A-level questions of permutations and combinations in math. Okay. Well, yeah, those are the actual questions you. See, that's the essential difference between combination and permutation. The actual questions can get pretty difficult. So you asked the question, just what's the difference, and that is the difference. But we could see an actual example of a question. I'm probably not going to be very good at it. Dude, please. Oh, good. You're just not going to work. What website? Oh, maybe. Okay, fine. I can have examples. That's cool. Okay, cool. Well, let's look at example A there. Actually, you tell me. Do you know how to do a problem like this? Simply facts. A factorial, B factorial, C factorial equals A factorial plus B factorial plus C factorial. I don't know how to do that problem. Dream Guy, welcome back. You do a bit. You get the wrong answer somehow. Okay. So let's think about it. I haven't looked at the answer yet, so let's see if I do this right. But bananas is 1, 2, 3, 4, 5, 6, 7 letters. So 1, 2, 3, 4, 5, 6, 7. But so I really like, we're talking about permutations because the order is important here. Because that's how you spell a word. And so I literally, like, I make a slot for each thing, and I think about how many options we have in each slot, and then you multiply all the options together. So the first slot, I guess we have 2 options because the B and the S must be at each end. They don't say the B has to go first. So the first slot, we could choose B or S. So I'm going to say that's 2 options. And then at the very end, it's whatever one we didn't choose. So there's only 1 option there. I wonder if there's... Now it is in a little bit of a weird way where all of here in the middle, we have 5 letters to choose from. There's a lot of repeats here, but I'm going to deal with the repeats at the end. So I'm just going to worry that we have 5 letters to choose from. So this slot here, we have 5 letters to choose from. Now we've used one, so the next one we only have 4 slots or 4 letters to choose from. Then 3, then 2, then 1. So that bit in the middle is 5 factorial. And so now we literally do 2 times 5 times 4 times 3 times 2 times 1 times 1. And the middle bit is 5 factorial. So it's going to be 2 times 5 factorial before we've adjusted for repeats. And I think I'm about to agree with here. Now the way you deal with repeats is that we have 3 A's that are being repeated here. So you divide out 3 factorial to account for the A's. And then you have 2 N's repeated here. So you divide out 2 factorial to account for the N's. And now you just calculate this thing, and that's going to be your answer. I think that's 20. Because it's just 5 times 4. So let's check the answer and see if I did it right. Hey, 20. Okay. So they explain it a slightly different way, but they get to the same result. So, I mean, I'll link this page to you too, and you can like read through that version if you want, but I like the way that I did it. A math genius? I don't know about that. No worries, simply facts. So yeah, that's the way that I love to deal with permutations for a problem like that. It to me, it was just pretty intuitive. Yeah, I was about to ask if you wanted to look at this one too. Let's see. So again, I haven't looked at the answer. Oh, come on. Ah. I'm knocking things over. Sorry if those window sounds are coming through the stream. I don't think they are, actually. Okay. 10 ways are there to rearrange the letters in the word oranges if the 3 vowels A, E, and O must be together. Um, you deal with these. I think we start by thinking about everything that's not A, E, and O. So those are 3 vowels. So we have 1, 2, 3, 4 consonants. So 1, 2, 3, 4. So thinking only about the consonants for now. In the first slot, we have 4 options, then 3 options, then 2 options, then 1 option. So we've gotten every possible combination of the consonants. And now we take all of those permutations and we're kind of, I think we think about inserting the vowels. Oh. We think about inserting the vowels as a block. Okay, this one has a couple of moving parts. So for now, I'm just going to treat these as a unit. And so we can take all the combinations we have here, 4 factorial, and in each permutation, we can put them here, 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 or here. So that's 1, 2, 3, 4, 5 options. So I think this isn't going to be it, but we're going to take the 4 factorial and multiply it by 5. But there's a trick where they only say A, E, and O have to be together. They don't have to be in the order A, E, O. So this big block here has a couple of different permutations of its own. Annoyingly. So I think how we account for that is we kind of do the same thing. Instead of just AEO as one single thing, it's going to be 1 slot, 2 slot, 3 slot. 3 options, 2 options, 1 option. So that's 3 factorial. So I think we're going to multiply in another 3 factorial. I'm not that confident in this one, but I think that's my answer. Let's plug it into a calculator and see what number that is. 4 factorial times 5 times 3 factorial. 720. And so a sanity check we can do is let's look at the total number of arrangements for oranges with no restrictions. So that's what? 7 letters? So let's see what 7 factorial is. And we expect the number that we got to be less than 7 factorial because we're taking away options when we put a restriction like this on. So if our number is more than 7 factorial, we've definitely done something wrong. Jed is saying 50-40. I'm just making sure okay, yeah. I want to hear you rinsing the answer to a different one. So 50-40. So our answer is less than 50-40. So it passes that check at least. So that's a good sign. Doesn't mean we're definitely right, but I think let's check the answer against the website. For part 1. $720. Oh, yeah, that's maybe a more direct way of thinking about it. I ended up doing the same thing, but they do it a bit more cleanly. Okay. Let's look at part 2. Understand better now. Why do you multiply by 5? Okay, so that 5 fact, It's because the factorials are just kind of a convenience thing because I had 4 times 3 times 2 times 1. So the 4 factorial happened to come up. But I'm always I'm always thinking about just the number of options for each part. And so this block has 5 options. So oh, you might be asking a different question. So I thought you were asking, why did I not do 4 factorial times 5 factorial times 3 factorial? Like same thing, just another factorial there. Was your question actually, why didn't I do 5 factorial times 3? Oh wait, yes. Okay, so you said yes to this part. Okay. That's because the factorial just kind of never rose out of this. This big block has 5 options for where it can go. And so when you have just 5 options, that's just multiplying by just 5. If the factorial happens to show up, that's when I'm only thinking about the options. I'm never using a factorial anywhere in this so far, at least. But yeah, it's true. If you think about it differently, you could have gone straight to figuring out 5 factorial times 3 factorial. And Math Major is pointing out that 3 factorial equals 6. So you could also say that's 6 factorial in one go. I don't know how you would interpret that, but maybe there's an interpretation there. That's not important, as long as you get the right answer. I'm using different combination of numbers, and I have a different way to solve the problem. Yeah, I think I agree with that, Math Major. 5 different slots of vowel sequence can be placed in. Yeah. 3 vowels must not all be together. Okay. Oh, so for part 2, okay, I see what Jed is saying now, where 2 is easy after 1. You have to know the trick. And actually, it's convenient that we got this number up here. So we know with the 3 vowels must not all be together. This would be really annoying to use the same procedure we just did here, or like a similar version of it. Because it's really easy to group the letters together. It's really hard to split them apart. Yes, perfect. 50, 40 minus 720. Take the total number of permutations possible and then subtract out the ones where they're together that we just got in part A. Mental math, don't fail me. 4,320. Yeah. Made it clear? Awesome. Yeah. 3 vowels must all be separated. Ooh. Three is tricky. Um, they do 4 factorial times 5p3. Oh, yeah, okay. And so Jed is saying it seems similar to 1, and I see why now after seeing this. So, okay. Yeah, yeah. Okay, so we start this one by thinking, we're going to do a similar thing as we did in part 1. Let's think about the consonants first. We have 4 of them. 1, 2, 3, 4. And that's going to be the same 4 options, 3 options, 2 options, 1 option. So that's the 4 factorial. But now for the vowels, in order for them to be separated, we could put a vowel here. Let me actually do a different color. We could put a vowel here, 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 or here. So we have 5 options to choose from for each vowel, but we only have 3 vowels in total. So we're only ever going to choose 3 out of these 5 slots. So like here, here, and here, or, you know, here, here, and there. So that's where the 5p3 comes from, because it's permutation, because choosing this for A and that for E is different from the reverse. E here, A there. We're never using all 5 of the slots, and so that's why we have to do like 5p3. I'll put that in a green box to symbolize that they're linked. Yeah, that's clever. So they didn't do 5c3 for the reason that I just said. If it's because you can choose the same 3 slots, let's just say A, E, and O. If you do combination, it's going to say that A, E, and O in those slots is the exact same thing as E, A, O. But we want to count those as different things because they create different, like, I guess, words or arrangements of letters. And so permutation counts those separately. Combination would count them as the same thing. Basically adding on how many ways you can put 3 balls in 5 slots, yeah. First order the consonants, then choose 3 with 5 spots in 1 vowel, yeah. And color cone, I think it's more numerical coincidence. If you change the number of vowels to 4, you don't get a nice answer. Oh, yeah, for the 6 factorial bit for part 1. Yeah, it's probably... Yeah. It's a good point. Yeah, simply facts. Those are some instructive questions. It's 1440. Okay. So those were all permutations. So, I mean, there's no one else asking a question right now, so if you want to keep on talking about it, I definitely don't mind. Out of curiosity, I want to see what their combinations questions are like. Oh, okay, that's a nice little thing to remember. Can you please do one more question? Yeah, I mean, that's the end of the website's permutation question. Sorry, one second. Sorry about that. So yeah, we can take a look at a combination question, I guess. Just means to take a break already. Yeah, I'm probably not going to stream for much longer, but I'm still going. You shouldn't be sorry for leaving either. You'd probably be sleeping. Wouldn't blame you. All right, so let's take a look at this one on combinations. Probably on a new page. Okay. Start thinking about this one. So you have to choose 4 books from reading list to take home over the summer. There are 4 fantasy books, 5 historical fiction books, and 2 classic books available to choose from. And how many ways can Oscar choose 4 books if he decides to have 2 fantasy and 2 historical fictions? Okay, so okay. I see you guys like you have them to both be from India. Don't feel pressure to say more information than you're like comfortable saying though. If you want to say anonymous, that's up to you. So how many ways can you choose 2 fantasy books and 2 historical fictions? Well, from the fantasy books, you have 4 total and you're choosing 2. From the historical fictions, we have 5 total and we're choosing 2. Yeah, I think it's gonna be what Indian Scouser is saying. And because I have the word "and" here, I believe you want to do multiplication. And so we can just calculate those 2 things. Yeah, sure, I can repeat. So we're choosing, in the first one, we have 4 fantasy books total, and we're choosing 2. So the order doesn't matter because you're buying the same books anyway. So the first one is 4, choose 2, because 4 things total and choosing 2. The next one for 2 historical fictions is you have 5 things total, and you're choosing 2 again. So that's 5, choose 2 from that piece. And then because they're asking "and," I believe you want to multiply these 2 things together. That's the part where I'm not so clear on the interpretation. But that's something you can plug into a calculator and get a number. Oh, yeah, Wolfram Alpha, that's what I wanted. Combinatorial computation. There we go. 60. Let's check that. Okay, 60. All right, let's work on part B. 2. 3 streamers from Pensaverse Live, you're the only one doing math. Oh. I mean, I'm just as guilty of streaming games as anyone else, so I can't judge. Questions like that is what screws me up. In case I'd be writing down stuff in a notebook. Yeah, these questions are really tricky. For the next one, at least one type of each book. So that means we want a fantasy, historical fiction, and a classic, and then a wild card. So I'll say fantasy, I'll say HF for historical fiction, and I'll say CLA for classics, and then I'll say any. So if we want one fantasy book, that's 4 fantasy books total, and we're choosing one. If we want one historical fiction, we have 5 historical fictions, and we're choosing one. If we want, this might be a crappy way to do it. Yeah, I just realized there's a different way to do it too, but this should also work. Classics, there's 2 available, so 2, choose one. And now for the any, we have 3 remaining fantasies, 4 remaining historicals, and 1 remaining classic. So 3 plus 4 plus 1 is 8, last I checked, and we're choosing 1. And when it's choose 4 choose 1 is just 4, 5 choose 1 is just 5, 2 choose 1 is just 2. So it's going to be, and we're multiplying all these together. So we're doing 4 times 5 times 2 times 8. If you don't trust that, you can no? You have to divide by 2. Really? I have any because we are buying 4 books. We have to choose 4 books. Oh. Okay. That's annoying. Okay, so Jed is saying we have to divide this by 2, and I think that's right, because... Okay, that I want to do it a different way entirely and see if we get the same answer. And Indian Scouser is saying a different formula that I haven't heard of. But it might also work. The reason we have to divide by 2 is because the classics, there's only 2 classics books total. So if we choose an extra classics, like, it's not a true choice. I feel like there's a cleaner way of explaining that, though. Wait, really? Then I don't understand why we need to divide by 2, Jed. Oh, I see. Okay, so I'm sorry, Simply Facts. Yeah, I misunderstood here. I'm dividing by 2 because I did this like a permutations problem, but there's always going to be overlap. Like, it's going to be like a repeat almost, where this any is one of the fantasy, historical fictions, or classics, and it doesn't matter which order they come in. And the way that I'm doing this, the order matters. Like, it's saying that these are different things, where if you buy 2 fantasy books, it doesn't matter which one goes in the first slot, which one goes in the last slot. And so that's like a repeat, and you have to divide it out. So you have to divide it out by 2. Famous, this is called like combinatorics, or like counting. And so I think this will get you your answer. I think there's maybe a different way we could think about it too. Let's get a number here though. 20 times 8 is 160. The first 3 and the fourth are ordered. Yeah, Peach D. I did this in a way that it's like, it's ordered, but we don't want it to be ordered. It's the answer? Okay. Let me explain this in a completely different way too, that kind of avoids this weird dividing by 2 business. I think we could also say that if we're buying at least one of each type, then let's just go through each case. So we could buy 2 fantasy books and 1 each of the other 2. So we could choose 2 fantasy sets, 4 choose 2, times 5 choose 1, times 2 choose 1. Or, so that's a plus for or, we could choose 2 historical fictions in one of the others. So that's 4 choose 1, times 5 choose 2, times 2 choose 1. Or we can choose 2 classics in one of the others. And hopefully this gets the same answer. I'm gonna have to plug it into a calculator. But this is much easier for me to think about. Hey, $10. It does get the right answer? You check? Okay, nice. So this way is a lot more tedious, but I feel way more confident doing it that way than I do doing it this way. But they both work. And the top way is a lot slicker. All right, so there's just part 3 left. Saturday, it's pretty good. We've been talking about some combinatorics questions with simply facts over in the YouTube chat. Other than that, I've just been struggling with mechanics like usual. You finally have a Saturday off too, or I hope that your Saturday is going well. It's just a part 3 here, and then that'll be the end for that question. But when do I go live? Right now, I'm just going live on Saturdays, and randomly. Playing Dredge, nice. How far are you? But no, right now just like Saturday starting 3 hours ago, whatever that is in your time zone, and the rest is random. Oh yeah, trust memes, that happens a lot. Yeah, I mentioned in applied math. I did that just this morning, Jed. Yeah. Got to the mangroves now. Ooh, okay. That's a cool area. How do you know that you're live? You basically would have to sub to the YouTube channel and check your sub box. There's probably a notification setting if you want to get an actual like notification. Isn't like YouTube has like a bell that you ring, right? I feel like I've heard YouTubers telling me to ring it, and I never have in my life. How does that work? Permanent exams just popped in and check your math skills. Yeah, nice. I'll take it. Oh, maybe I shouldn't do it. I should do it on someone else's video, not on my own. Oh, sorry. This is just a random video. how do you get notifications? I don't know. I don't know how YouTube works. I'm sorry. I don't know how that part of it works. But yeah, if you're on Twitch, I also stream on Twitch too. And then simply facts. Do you want to talk about part 3 here, and then we can wrap up this, or we can like stop there? Yes, please. All right. So for this one, we're buying 4 books total, and we want at least 2 of them to be fantasy books. I bet there's a neat way of doing this, but I kind of want to do the same approach as like this here, where we just look at each case. So we could buy, there's 4 fantasy books total. So there's a scenario where we buy all 4 of the books as fantasy books. So 4, choose 4. Or we could buy just 3 fantasy books. So 4, choose 3. And then 1 of the others. So we could buy 1 historical fiction book, 5, choose 1. Or, oh god, this might get a little dicey. We could buy 1 classics, which is 2, choose 1. Oh, really? Just memes? Yeah, I'm sorry. I never want notifications, so I don't know how that actually works. I'm gonna be honest. I don't like getting pinged for things. I'm like, I will say OCD. That's not the right word. Like I'm anal about it. I'm West Coast. I couldn't find the bell icon when I was just looking at a YouTube video. I don't know. I just do the acting stupid and doing math part of streaming. You're in the East? Oh, nice. So that's all for fantasy. Oh, you got 3? Okay. No worries. I mean, just so I know, I want to see this out to completion. That is just for my own sake. You don't have to pay attention to this. Oh yeah, this gets a little cumbersome quick. In the case for 2. I mean, it's not that bad. I think that would be my answer. There must be a neater way of doing that though. I don't know. I'm gonna type this entire thing into Wolfram Alpha. Bruh. This is the real reason why you don't do this manual accounting crap. It's a pain to type into the calculator. That didn't even... Dude, Wolfram, you suck. Ugh. Alright, see ya, Simply Facts. Total combinations minus combinations with 0 fantasy minus combinations with 1 fantasy. No, Wolfram Alpha is great. I'm just not doing it in an efficient way. And Indian Scouts are maybe saying the same technique. How do you get the combinations with no fantasy? You still have some work to do there to get those two things shed. Well, yeah, but you still have to do all 5 you still have to do a case for all 4 being historical, or 3 historical, 1 classic, 2 historical, 2 classic. Unless you have no efficient way to deal with that. Seven, choose 4. Oh, maybe it is that simple. No, it's not that simple, because you're choosing... You can only choose at most 2 classics. Not all these books are the same. If you blindly do 7, choose 4, you could be choosing 4 classics. And that's not possible in the question. Okay, well, the premise at the top, the part 3 is at the bottom. I don't know which part you want to see. I'm in California. We don't really get snow here. Unless you're in the mountains, but... In most of California, you don't. You're in the waiting room? Oh, okay. Let's talk. Hello.
Hey.
So, I don't think 7 choose 4 is ever valid to do here, but...
What I'm considering is if you're looking at how many combinations there are that contain at least 2 fantasy books, I'm going back to my premise of consider all the possible combinations that exist.
Right.
Then remove any combinations that have 0 fantasy and any combinations that have 1 fantasy. So to calculate the number of combinations with 0 fantasy, you take those 4 fantasy books out of the pile. So now you have 7 books to choose from. Choose 4.
Yes, except... Well...
You can pick both classics and 2 historical fiction because there's no restrictions on that. It just says you have to choose at least.
Oh, I think you're right. Yeah.
So
okay.
7 choose 4 would be the number of 0 fantasy. For 1 fantasy, you have 7 choose 3 times 4, which is the number of fantasy options you have for that 1 fantasy book you're going to keep.
Huh.
So you end up with a total of 11 choose 4, which is all the possible combinations. You subtract 7 choose 4, which is the number with 0 fantasy books. And then you have 4 times 5 choose 3. Or 7 choose 3.
Wait, what?
Go back. I'm gotta see
the
numbers.
Oh, you need to see the book counts, yeah.
The book counts, yeah. So the initial one is there are 11 books to choose from. You choose 4. That's the total number of combinations of choosing any 4 books you want.
Okay.
Then if we're choosing no fantasies, you have 7 books left over. Choose 4 of those. So we're going to subtract 7 choose 4 from 11 choose 4. And then we're going to subtract all the combinations of choosing 1 fantasy. So you got to, again, choose from those 7 non-fantasy books, but you're only going to pick 3 because you know the 4th one is a fantasy book. So you have 7 choose 3 times one of the 4 fantasy books. 4 choose 1.
Let's see if that gets the same answer. Yeah, I think I agree with that.
Just a slightly different way to
It's a lot
And
faster if it works.
if you want to be more specific, 4 choose 1 times 7 choose 3, because you're choosing 1 fantasy book and 3 of the other 7 books. And again, it's combination, so it doesn't matter.
Yeah. Okay, I can do the old-fashioned way. Choose 11, 4 minus choose 7, 4 minus 4 times choose. What was that last one? Was 7, 3.
4, 7, 3.
155, and survey says 155. Nice.
Hey,
How do they say to do it? Oh God.
yeah,
They do it
doing
my
the way that you
manual
did
way.
it.
Even worse though, I think.
They're not doing the second option they did, the alternative method didn't even do that way, did it?
Uh
Yeah, you're choosing not fantasy. So you have 4 fantasy and 7 not fantasy. How many ways can you choose? 2 and 2, 3 fantasy and 1 non-fantasy, 4 fantasy and 0 non-fantasy. So it takes the whole.
oh yeah, okay.
It basically simplifies the problem, I guess. So you don't have historical fiction and classics as 2 different categories. They're all just non-fantasy.
Okay, nice.
So that's equally as easy, I suppose.
Yeah.
Still three combinations that you have to manipulate rather than 6.
Yeah. And make sure you don't like forget a case with the long way.
Yeah, that's the fun thing about combinations and stuff is you can choose to approach it from so many different ways,
Mhm.
as long as you make sure you're not counting the same options twice.
Yeah, that's always what gets me.
Yeah,
Okay. Well, thank you for the help there.
yeah, well, it was a fun discussion, fun topic.
Yeah.
Something I can understand. That magnetism stuff is way over my head.
Yeah, I mean, there'll be less of that
I mean,
now.
what?
Still some, but
I mean, I guess I could just say I'm not attracted to magnetism questions, and I'll show myself out now.
oh my God. All right, fair enough. See ya.
Yeah.
Okay. Catch up with chat. Indian discussor agrees. Goes around with my FYP in the daytime. Oh God. Yeah, I don't know. Yeah, it is an interesting approach. So side. Mixture inputs, outputs, domains, ranges, left side should be X independent variable, right side Y dependent. Yeah, famous. That sounds about right. Should swap in the books for a book on math combinations. True, Orange Hue. And polarize against E and M. Yeah. These are closely related to probability questions, twist memes. For many probability questions, like these are a step along the way. What's a good example? I don't know. Okay, I don't know the exact right phrasing for the question to make sense here, but there could be a question like, what are the chances that you get 2 fantasy books and 2 historical fictions? And so you would take like your answer for part 1 and divide it by the total number of combinations. And that's a probability. I don't know if that exact question is possible with this question's constraints, but it's something like that. Polarize against E and M. It was super cool. I'm reading through chapter 8 on my own right now, and then I want to get through chapter 10 and 11 too. But I don't know, it's just cool to learn about Maxwell's equations. They're just neat. All of classical E and M in these 4 equations here. Like in theory, I think you need to start from the beginning on my own. Yeah. Like we've plowed through a lot of stuff, but there's only a lot of stuff that we've gone over that I'm not that solid on. So I wouldn't say my understanding of it is very deep. Where was I in the mechanics? Oh, I was ugh. God, this question is such a pain. You know, electricity markets in my everyday work. Oh, neat. What do you do? Or you don't have to say if you don't want, but get rid of that one. Get rid of that one. Okay. Different mechanics of probability goes hard. Yeah. Okay, so that was the question I was working on, but like I kind of don't want to work on it. Debating just kind of calling it for the day. I worked through part A and I was working on part B. Forecast curtailment risks for renewable project developers like 5 to 10 years down the line. Ooh. That sounds fancy. Hey, Smiler. How's it going? Nice to see you here. That sounds like a nice gig. Scouser. Ugh. Okay, so the issue that I was having with this is that either my on the way down equation is, I mean, I could all be wrong here, but my on the way down equation is either wrong or I'm not interpreting it right. Maybe it's okay. What did I have open in decimals? Here. So this really has a constraint that 0 is less than x is less than what is x less than? I should 3735. There. Okay, so I think this red line makes sense for the first part of the velocity on the way up. Oh, sounds good, Scouser. See you later. And this green line would only start 3735 is less than x. And we'll need an upper bound on that at some point, but we're not going to worry about that yet. Now, in theory, this line segment should start from 0. So that doesn't quite make sense to me. Oops. Like it should have the constraint that like it needs to meet this line here. There shouldn't be a discontinuity. And if I can just figure that piece out, I think we'll be okay? Question mark? Right, correct. We could shift it, and I could just do that arbitrarily, but if I should happen naturally, like, I should get that shift just from the physics. There's a wormhole near the box? Maybe. And so the fact that I didn't, I don't have, or the fact that I have this continuity means that I set something up wrong from this problem. It does mean that I'm bad somehow. It's definitely a skill issue. Pretty much, correct. That's what most stream days been me staring at mechanics problems. It's off by 1, or if now that's a flip sign. Yeah, it's always like the smallest thing. Oh, twist means this is a really difficult version of mechanics. It's usually, my actual mechanic classes have been way easier than this. I'm studying out a really challenging book. That makes me, well, not hate mechanics, because I would hate it if it was easy, but it really challenges me, and like it does get frustrating sometimes. Oh wait, maybe we need a shift, because these t's are not the same t. It should only start behaving like this after this time. So maybe we actually do get to shift it, because I'm doing this like a piecewise. Maybe I shouldn't. Joe, how's it going? I've had this issue before when I tried to be too mathy with these physics problems instead of piecewise equations. This might actually not be wrong. I would need to offset it by this amount here, in theory. Let's plug my example numbers into Desmos and see if that shift would make it match here. 5 over 9.8. Oh! It cuts off for some reason. Thank you for the prime, dude. Appreciate ya. How goes the math? Pretty good. Right now I'm just doing some like physics problems just for like studying. Oh, that's looking better. And now they're the same t. So I think we're actually okay. And yeah, just before this, we're talking about like doing counting problems, like how many ways are there to choose like 3 things out of 5, like those types of problems. What is that line at x equals 0? Oh wait, what part do you mean? Like it should be 0 at x equals 0. Because this is the block sliding up the incline, stopping, and then coming back down. It's going to have an end at some point, but I haven't figured that part out yet. You would have just asked ChatGPT by now? No, don't ask ChatGPT. Shift that 0. Oh, okay, yeah. And actually, this shift, I don't think it even matters. I might keep it just without the shift. Because what I think So the question is, find the times of the up and down motions. And I still find the question a little confusing. The way to, because the question seems to imply that the block, okay, so my issue with the question is that it then slides back down to the starting point. And so the block has an initial velocity v naught going up the plane. So it goes up the plane, it eventually stops, and then it comes back. Now the wording of the question to me implies the block stops again right where it started. And that doesn't make sense to me. I think the block keeps on going until it goes to the ground. Because I don't know why it would stop if it already started moving. And so the way I'm interpreting the up and down motions part is when does it get to the same height that it started at? And in order to figure that out, I think we need some integrals. Try as find Taylor series expansion of g of x such that g of x plus 1 minus g of x equals f of x for all smooth functions. What the hell? That sounds terrible. I don't know how you do that. Visible springboard pushing it back up? I mean, I would hope they would mention that. But the having that misunderstanding almost makes me want to look at the answer to see if I'm misinterpreting it or not. You already did it? Oh, okay. We'll have static friction able to cancel the weight projected. It would stop at the top if the static friction is able to cancel the weight projected in the direction down the ramp. Oh, okay. Oh, that disgusting thing? Okay. I remember seeing that. Yeah, Dr. L. So the problem is saying that depending on the angle of incline, if it's less than 45 degrees, the block goes to its highest point and then stops. If the incline is more than 45 degrees, it goes to the highest point, instantaneously stops, and returns to its starting point, which is weird phrasing to me. Because it would keep going past its starting point in my mind. But it would go through its starting point at some point. And so that's how I'm interpreting it, where like, when does it go back through its starting point? I just finished up a call with some people on the server explaining how I derived it. You really should have recorded it. What surprised me the most is that the program I derived, which clearly works, is nowhere to be seen online. I mean, I don't know how you search for that type of thing. To be honest, it seems hard to find the right like keywords. But it doesn't stop just a constant acceleration. Yeah, so like you could have two constant acceleration problems, which I think I've basically done for the way up, and then another constant acceleration problem for the way down. And I think that's maybe what part B is getting at. But it just, the phrasing of it is weird to me, where to me the wording of the question implies that it stops again, like a second time, and there's no reason it should, as far as I know. Unless it's just like, there's a wall at its starting point, I guess. If it doesn't stop, the acceleration on the same is the same on the way up and way down, no? No, the acceleration is greater on the way up because it's both friction and gravity are pulling it back. But on the way back down, friction is pulling it up. So there's more, it's slowing down faster on the way up. or the acceleration is great, or it's positive velocity, but a greater magnitude of acceleration, I think. Yeah, the friction changes directions. Use Ask AI instead? Oh, interesting. Okay. Question in part C is redundant? I haven't even read part C entirely, at least. 4 different precision, 4 different quotient, they're not really different. Oh, okay. If the slope is truly frictionless, then it must be slide on some sort of oil or lubricating substance. It would make things messy. I guess so. And there's a lot of like theoretical questions that wouldn't really happen in real life, but so yeah, I'm taking the question to mean, when does the block instantaneously pass by its starting point on the way down? And I think to figure that out, we need integrals. So we can figure how far it goes on the way up using this endpoint here. And then set that equal to an integral. We can probably chop off the translation. Can we chop it off? But it's something like that. I guess you don't have to integrate. Yeah, the acceleration it's definitely constant. It's different accelerations, but in each case it's constant. Okay, yeah, that's fair enough. The angle doesn't change, so the only force acting on the block is gravity. Time distance to go must equal time distance to go down. The thing that makes it different is the friction. The friction changes direction. At first, the friction hurts, and well, depends on the definition of hurts and helps, but gravity is always pulling down, but friction changes directions in one case from the other. So that's what makes the difference there. And so part C might be asking about that part. It's a nice problem. What's the answer? I mean, I could show the answer key, but I don't look at it for myself yet. I mean, if you made the problem, it will be 69, but Morin doesn't start with L, so I don't think you wrote this problem. What's that one equation for distance covered? I was about, I could just integrate it because I can't remember it. In that case, why solve it? True. I think it's like a 1D kinematics equation. Here we go. We can use this thing to shortcut. Let me copy that down. Vf squared minus vi squared equals 2ad. Just to get the distance covered for that first one. Who cares? I'm not going to scroll back to my other page. We're going to involve observing the graph and mathematical relationships so that you can determine whether it represents a function. Exactly, yeah. It's a visual interpretation of the definition of a function. Well, yeah, the essential restriction of a function, I guess. So final velocity is 0. Initial velocity is v0. Acceleration is minus g cosine theta. Oops, not like that. Like that. plus sine theta d, and we want to solve for d. 1x can't have 2y's. Oh yeah, for the vertical line test, right? Okay, so that's how far it goes on the way up. Then we want to figure out what do we want to figure out? We're asking about the time, so we want to know. Ugh, is this even helpful? The thing that I just did. Yeah. I don't. Okay, we can figure out what velocity is when it's gone this displacement. And I'm going to use this version of the equation. Actually, it doesn't matter. V final squared minus initial V squared 0 is equal to 2 times acceleration, that bad boy, times displacement is what we just solved for. The T in kinetic equations is really a time interval. You always need final minus initial. Yeah, for the sake of this case, just for like displacement, I guess it doesn't matter. But for actual distance traveled, it would. Or that's how I'm thinking about it. And I'm saying that VF is the same as... I want to figure out... I'm going to take whatever V I get from this and plug it on the left side there to find T. Well, that V, I'm going to plug it in for. And then I'm just going to know it has this offset. Just popped in. Forgot to ask a question. Any advice you got for getting the better physical calculation mechanism, for example, visualization, help with any other approaches? It's just kind of hard, to be honest. If you, what helped me a lot was having like the people in chat like guide me through questions, especially like Dr. Cook. But obviously not everyone just has people hanging out who are willing to like teach them stuff. For some things in physics, this website has a bunch of simulations that were helpful. So like the circuit simulator is helpful for obviously the circuit section, and then they also have simulations for electrostatics and magnetostatics, but there's some things that are just kind of difficult. And I don't really have a good trick for them, unfortunately. We're going to take the negative root. The G's cancel, the 2's cancel. I wonder if this simplifies. I feel like it doesn't. Back was feeding the dogs. Oh, nice. Definitely anything. I just have no idea what to do with what I'm looking at. Yeah, it's what kind of thing where you just have to like trust that it'll come up later, unfortunately. As weird as the plays we're getting, Those seem easier than these sliding wedges. No, I'm still grateful for not having pulleys involved. I feel a little scarred by doing all those Atwood's problems. I'm still not doing well on these problems with wedges, but I enjoy having the change of pace. So I'm taking this V I got and plugging it in right here. And I want to solve for T. This is an interesting... This simplifies. Does it simplify? Oh no, not... We just barely don't get a Pythagorean identity. We do get a double angle, but I don't think it's really helpful to do. Like, I feel like this, I may as well just leave it like that. I watched YouTuber Eugene's animation that helped a bit. Check this out. Awesome. Glad to hear it. Okay, so that does have the right units of time. It shouldn't have a negative though, right? Did I not want the negative root? I think that velocity is negative. I'm just gonna take the positive root and not question it, because we shouldn't have a negative time. You watched Eugene also? Oh, nice. I don't think I've heard of him. Okay, so we're saying the up motion takes v naught over g times cosine plus sine. And the down motion takes v naught over g times 1 over root cosine minus sine times cosine plus sine. Is that less? Or we expect it to take... The way down should be a bigger number. It should take longer to get to the same point. No? Yes, it should. Yeah, correct, it is. Does that simplify in a nice way? Yeah, but that's a half angle, or a double angle, isn't it? I feel like that doesn't really matter. Oh, wait. Oh, yeah, okay. Never mind. You're probably right. I was getting mixed up. I was doing the math work on my head. Yeah. Okay. No, yeah, you're right. I thought we'd get an extra +1 for some reason. We definitely don't. I thought that wouldn't be it. I thought we'd still get something else besides the cosine 2x, but we do not. So let's write it like that. Okay, so this number... Oh god, how do we compare this? Kind of off-putting weird at first. They can also be informative and get straight to the idea of things. Oh, funny. Okay. They feel like low-budget videos. Oh, okay. I mean, as someone who's made a couple of low-budget videos in my time, like I probably can't judge. Okay, so I want to compare that piece and that piece. And we're going to do that in Desmos. No. I don't know why I insist on putting the y equals there, but I do insist on it. We care between 0 and pi over 2. So for the entire interval, we're finding 1 over root cosine 2x is greater than 1 over sine x plus cosine x. And I think that's perfect. Because the time on the way down should be greater than the time on the way up. Okay. I think it passes intuition. I hope. Should we check the answer? You feeling lucky, punk? Number 17. Mechanics is the best? I like E&M way more. So far, at least. Wrong answer. I mean, that's the safe bet that I got this one wrong. This is for part B. A up, they're both positive. Okay, so I define my acceleration in the opposite direction, or I define positive in the opposite direction, but my equation for the acceleration otherwise matches for A up. V naught G over G sine theta plus cosine theta? Okay. And then the cosine becomes negative. Good. Oh my god. I did one right. At least one part right. I did one part of one problem right. Oh my god. That's crazy. Okay. Let's look at part C. Mechanics is the most intuitive physical science for me too. Or for me. Now I that's what I thought I would feel. I thought I would feel the same going into it. And this book completely destroyed that assumption. So some of the scenarios that they pose with like Atwood's machines and stuff just completely, I have no idea what would happen. I have no intuition. At least for E&M, I don't expect to have an intuition, but for mechanics, it feels worse because I feel like I should be able to figure out and I just can't. Assuming theta is greater than 45 degrees, is the total up and down time longer or shorter than the total time it would take for the same initial v naught if the plane were frictionless? Or does the time it take... Wait, what? Is the total up and down time longer or shorter than the total time it would take? Oh! The solution gets a little messy. Okay. So first off, let's use our answer from part B to get the total up and down time. Okay. Part C. So I think we have to work out the same problem, but now with no friction, and that's a lot quicker. Because those up and down times will be the same. I think we can say that. Can we say that? Yeah, I feel like we can. Oh, and journal plus is being done. Why does that? I don't get why OBS and journal plus interact in this way. It's very annoying. Okay. Regio? Or I'm probably pronouncing that wrong. In a shopping mall, there's a hall of cuboid shape with dimension 800, 800, 720 units, which needs to be added. So leave an escalator as shown by the dotted line in the figure. And find the minimum total length of the escalator. The heights at which the escalator changes directions. The slopes of the escalator at the turning points? Well, that feels a little weird. I'm not sure that I understand what's happening with the question. But there definitely sounds like there's a figure involved, and I feel like I need to see the figure. Do you have a Discord? Would you be able to post a screenshot of the problem in there? Okay, so here we only have one acceleration, which is mg sine theta, right? Or is it cosine? Sine. And I'm going to make it negative to match my part B work. And so that means the velocity is v naught minus mg sine theta t. And so we set it equal to 0 to solve for t. Those units can't be right, because it's MA equals that. Okay, and then I think we can, like I said, we can safely assume that the total time, up and down time, is just twice of that. Because the acceleration is constant. And so they want us to compare the frictionless answer to the answer with friction and figure out which one is shorter. And so I assume that's where it gets messy. So we're just going to say, I don't know if we want equals to, maybe question mark equals to, because we're investigating it, to v naught over g sine theta. Let's keep mean equations even if it's 1, easier to compare changing frictions then. Oh. Yeah, true. I'm not going to go back and edit all my work, but that could have been an interesting thing to look at, yeah. It does make it harder because you have to do sometimes static and sometimes kinetic, I guess, but I guess it'd be mostly kinetic. Okay, so the V naught G's cancel. Least upper bound skeleton. Do we want to multiply through by sign or like? Yeah, this is actually. They say this problem gets a little messy, and I assume that means they want me to solve this algebraically. Oh, I'm sorry, Regio, or I'm sorry because I feel like I keep on saying it wrong. But if you want me to look at a problem, I will. It's just that escalator one seems a little hard to understand just in text. The letters of the word IITJEE are permuted in all possible ways and thus are arranged in a lexicographic order. Find the rank of the word IITJEE. I haven't heard of the rank of a permutation. I'm going to Twitch chat in case someone wants to read it too. The rank. That's a new one for me. Oh, wait. Oh, lexicograph. So like alphabetical order, I think. Maybe. So is this asking the question? Like, if you list all the permutations of IITJEE, you'll have like the very first one, and you put them in alphabetical order, is like EEJIJ. IIJT will be your very first alphabetically ordered permutation. ... for all the others. You would eventually have IITJEE ... and then whatever the last one. I guess it'd be the reverse of the first one. Would be your last one. I think the question is if that's number one and that's number whatever, what number is that one? That's how I'm interpreting the question here. And the numbers are small enough that, or the word is short enough that I wonder if we can just kind of do this manually. Go first off, how many total permutations are there? We have 6 factorial letters divided by 2 repeats divided by 2 repeats. 6 times 5 times 2 times 3. 30 times 6 is 180. Okay, so well, I guess it'd be from, yeah, it's 1 to 180. Okay. And we need to know where this falls in that list. Huh. That's an interesting problem. How would we do this? So with 180 permutations, probably a few too many that I would want to do manually. I'm trying to figure out a permutation way we can do this. Like, what constraints can we put on this? Do we expect this to be towards the beginning or towards the end? Probably towards the end, because it ends in EE. Oh, actually, yeah, it looks very similar to the last one, I feel like. What if we try working from the bottom up? I'm just trying to think about the process. Maybe we'll see a pattern and get to shortcut it. Or maybe it's close enough to 180 that we can just do this manually. Code this up pretty easy. Oh, yeah, that's true. The one that comes before this one, what would that be? I mean, I assume this is a JE question. You don't get to code your answer, but it would be a nice like coding problem too. I think the one before this, is that right? No. The J would move back one by one, I think. I think we're already nearly there. Just by doing this process by hand. It's maybe a better typing. I should maybe type this list instead. Just for legibility. Okay. And so I think just kind of continuing this process out, I think we've done everything possible with T in front, and now we do JT? Maybe group the letters together? I mean, we are always going to have the E's on the end doing it this way. I don't know how else to group them, though. And so that's all the ones that start with J, I think. Is this right? Why did the E's never get affected? Am I missing something? I don't know how you do this like the math way. There's got to be some kind of pattern you can pick up on. This might be a Googler, because I definitely could code this and it wouldn't be too hard. But I'm getting a little confused just on arranging things alphabetically, to be honest. I think I'm doing it wrong. The answer is 72. I think this website has a paywall. Oh, a video solution? Wow. Are you gonna paywall me? Oh god, that's loud. Sorry. Oh, that's smarter. You do all the ones with the E first. You just look at different cases. Okay. Then all the ones that start with I. Interesting. Okay, let's see if we can work that out for ourselves. Because I think I was... This is not good. So it looks like what they were doing in the video is, you know, alphabetically, you're basically going down the list and counting, instead of manually arranging these, we know that everything starting with E is going to come before anything starting with I. So we can figure out a part of how many things are between these two. Not all of it. But if we start with E, then we have 5 factorial choices left over. But we do have a repeat because the E is repeated. Or sorry, no, the I is repeated. The E, we've accounted for one of them. So we do 5 factorial over 2 factorial. Is 60. And then we have to look at I comes right after, or I is the next one after E. So then we're getting into starting with an I. What we want is I before E except after C, true. And so IE is the only other case that comes before that, right? So we have 4 factorial left over. And no repeats because we already used an I and an E. If the answer is 72 though, then that needs to be cut in half. And why would that be? Because oh wait, it's not the first I though. I think I'm... What is the answer supposed to be? Please get rid of the player controls. I can't see the math. Okay. Oh wait. Also, I'm not off yet. 96. Okay, so we're just seeing... the 72 that I saw was something else. Okay, so I think we're okay so far. So we've accounted for... All of them start with E. All of them start with IE. But we also have to worry... Do we? Oh yeah, so now we have to worry about... It's not the first I. We have to worry about everything that comes before this T. So we have to worry about IE. We have to worry about I. Well, not I again, because we're out of I's. So I guess J. No, J doesn't come before I. Is that all we have to worry about? No, yeah, I, J, because we have a T. Yeah, the alphabet is hard. Thank you, Peach Tea. So that's going to be 3 factorial. This one is going to be 3 factorial, but divided by 2 factorial because we have 3 E's in there. So 60 plus 24 is 84. 84 plus 6 is 90. 90 plus 3 is 93. Was that what the answer was? I don't remember. 96 ways. Wait, what? IIJE? I thought I accounted for that. IIT. Oh! Dang it, there's a 4-character case, I think. Because J, E would come in before the J. Where do we use J? IIT E 2 factorial. Yeah, because IITE would come before IITJ. So we have to account for that too. But now I need to add one more case on. And that's that case I see, but I don't understand. Oh, you have to count the case itself, I guess, to get the rank? Huh. Okay. I can go with it. So 84, 90, 93, 96. You add them all up. Okay, so that's a pretty crappy explanation, but I'll drop the link to this video in the YouTube chat. Let me know if you have any questions about it. I think I understand it. I just have a hard time doing those on my own. A lot of combination ones today. I don't want to get rid of this work in case you ask a question about it. Talos! Thank you so much for the raid. Welcome in, everyone. Oh, you're doing Keep Talking Nobody Explodes? How'd it go? Thank you. And Generic Mime Toter, thank you for the follow. Welcome in, everyone. If anyone's new here, I'm Don. I do math streams and I also do game streams. So right now it's just a math day. We're just talking about this question here. And with the help of a video on the internet, we were able to solve it. And yeah, decently considering we hadn't done it in like 3 weeks. Nice. And yeah, for anyone who's here on my end, please check out Talos. He does a lot of game streams, but if anyone asks, he'll switch, or if anyone asks a question, he'll switch over and solve that question. So I'm not new here. Are you still Don? No. If you're not new here, I'm no longer Don. Oh, you did redeem a quick math. 1729 minus 12 cubed? Okay, you're breaking the rules of quick math, but there must be a trick for that if you're asking something so weird, right? They don't have a common factor, do they? No? Is there a trick for that? 1729 minus 12 cubed. I don't know. What's the trick for that skeleton? No trick? Oh, you're just being mean. Yeah, I mean, I don't know what 12 cubed is. Okay, well, the quick math has specific rules, and you're just shitting all over them, but I'm used to it. What's 144 times 12? It won't be quick, but it'll still be math. 2 1 4 4 0 8 2 1 7 17. Oh my! It's 1. That would have been a good guess. Rotetto got it. Yeah. That's the old. Oh, there's a story. Okay. The vertical line test where you can determine of a mathematical equation in a graph as a function by drawing vertical lines if it touches one point. Exactly, yeah. That's perfect, Hamished. Oh, it's pronounced more like Romanuzan, I think. I always get corrected on my pronunciation. I always forget how to actually pronounce it. That reminds me of what's his face? The one number theory guy, Fermat, with powers of 2. But it's 12, so it doesn't quite work. But yeah, before Fermat, you know what? I'm taking your points for that too, Skeleton. Okay, and so before we were doing that permutation question, we were suffering through some mechanics studying. So I work on this one, number 17. I've answered part A, I've answered part B, and I was working on part C, but it's kind of there's gonna be a lot of algebra involved here. I'll keep the question up on the screen for a second while I drink some water. Okay. Sounds good. I mean, to be honest, I'm probably gonna wrap it up after doing part C here, but thank you again for the raid tells. I hope your errand goes well. You once said a geometry problem was sort of quick math challenge and it had a funny answer. Oh yeah, I remember that one with the harmonic mean. Okay, and then I got it down to this stage, and I want to figure out if the left side is greater than, less than, or equal to the right side. And so I'm just using an equal sign, but should I be using an equal sign? Should we like use a greater than? They're longer or shorter. I feel like I should use an inequality just to remind myself to follow the inequality rules, but I'm just going to randomly choose greater than because I don't know what it should be. Well, okay, there's an immediate issue where, okay, we can say 0 is less than theta is less than pi over 2. Sine is positive. Root cosine 2 theta. Oh. I don't like that. Because cosine of pi is -1. Isn't that an issue? And that's an issue with the... Wait, how did the book put the answer to that question? The book left it in that form. Interesting. I'm going to leave it in that form too then, instead of simplifying it. So that might be for a reason. Oh, that makes the problem a lot bigger. We got a big part problem on our hands. Sine theta plus cosine theta. Sine theta minus cosine theta. I think the real answer to this question is just to use a graphing calculator. But we're going to do it the long and painful way. Okay. 10 to the 101. That's a 1 with 101 zeros after it. Do I have to name the actual... figure out what the name of the number is? Please do. Oh my god. I don't know the... We'll see what Wolfram Alpha says about it. I don't know it. Duo trigintillion? What? It's 100 of those. It's 10 times a Google. My god. You know, I'm taking those points too. Toast Wizard, thank you for the follow. I do like taking your points. Okay. And Brotato, thank you for the follow. Now we're getting the meme. How many ones is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A minus sign, Peach Tea? Okay, so we're going to count that one as 11. 12, 13, 14. Oh no. 15, 16, 17, 18, 19. Another minus sign, so that one is 19. 20, 21? Now, I might have lost my track. I lost my place when those two chat messages got put, but I'm saying 21. Is that what it is? It is. I did it right. Okay. Just gonna go with the yes. You didn't even count it. I respect that. Oh. Okay, so if I multiply each side through by sine theta, that's safe. That's always a positive number. If I multiply each side through, what I want to do is get rid of all the fractions. So I'm thinking if everything is positive or negative here. On 0 to pi over 2, that's positive. Yeah? Okay. I've convinced myself. By the same logic, that's always positive. It's a square root, so it should always be positive, but I was realizing that you might have a negative sign underneath the square root, and I don't know how you deal with that. Oh wait, it's not this. It's this. Because we're saying it's always more than 45 degrees. Yeah. So if theta equals pi over 4, you get 0, but we're not allowing pi over 4 exactly. I need to do a test point between those. If you do pi over 3, you do get a positive number. So we're safe. Okay. I think these are all positive numbers, and we can get rid of all these denominators. Take a rest or touch some grass literally now. There's more math to do, though. How can I? It's greater than... No. Oh my god, this is such a long line. Square root of ugh. That's all I'm writing there. I'm just gonna know that it's this. I'm setting that equal to ugh. Okay, so, we have a really, basic problem here now that's very quick to solve. I think maybe we want to subtract this term over and factor out the radical. That seems like a reasonable thing to try. Square root ugh. And I'm going to multiply out the sine theta, because why not? If I had to focus Spain like you, I'd probably be acing whatever exam. I don't know, I just get really preoccupied with stuff. Oh no, I shouldn't write it like this. Minus sine theta minus 2 cosine theta is what it is. Square root ugh. Okay, what we could do here, subtract these terms over to the right side, divide out these terms, and then square each side. Just to get to deal with that square root. I also like how I'm just rolling with this square root of ugh thing. Now, this is a negative number, and we're dividing by it, so we should flip our inequality. It feels like there's simplification here, but I don't quite see it. Okay, and so now, if we square each side, I'm gonna get rid of the ugh. I am gonna refactor out the sign. Those aren't squared. Is 808 111 prime? No, I never pulled an all-nighter twist memes. I mean, I pulled an all-nighter just for fun once, but not for studying. I need my sleep. I know you can add the digits up and try dividing it by 3. 16 plus 3 is 19. Dang it. I don't know. I'm gonna say yes. But, I'm just saying yes for fun. Okay, I can divide out sine theta plus cosine theta. And I'm going to multiply Am I going to do that? Yeah, let's multiply the denominator back over to the left side. Okay. Take my points once again. Oh, I didn't even take your points yet. Is it actually prime? It is prime. I got it right. So I got your points. Actually, and if I'm wrong, I'm taking your points too. If you're... Who knows? It's nebulous. Another? Is there someone else in the YouTube chat? I only see you in the YouTube chat right now, Twist Memes. I mean, I've thought I've banned people before in the YouTube chat. Maybe I only block them on my end. If you do see someone else, then let me know. Because I want to make sure that I'm doing it right. Dude, this is a pain. Why am I doing this way? Okay, I'm gonna let Wolfram Alpha do this foiling. I'm gonna say x is sine theta and y is cosine. Well, that's not even that helpful. Okay, you know what? We're going. We're gonna take the original problem and Desmos it. I'm over whatever the hell this is. Okay, so 1 over sine x plus cosine x plus okay. And we're restricting x on a certain interval here, so let's actually type that in. Pi over 4 is less than x is less than pi over 2. And then the other piece of the equation is much simpler. 2 over sine of x for the same interval. Do people there usually join an external tuition or coaching centers along with schools? It's rare. It's not a common thing, but people definitely do it. They're like, we call them like after school programs. It's not like an expected thing usually. Okay, so it does depend on theta, it turns out. I don't know if that's a clean like unit circle value, but whether friction makes it go faster or not depends on the angle. So green is the time without friction. So for smaller angles, No friction is faster. For bigger angles, friction is a lot faster. It's kind of funny. Let's look at what the answer says. Oh, I'm spoiling the answer, Penbox, but it's 17. This one. Kind of interesting conclusion that I think we're about to make here, if I'm making the right conclusion at least. I'll have to go back to reading the answer though. Okay. Okay, yep, same equation that I set up, and they do it by hand. 1 over root 2? Is that my crossover point? You think you did it? Oh, I didn't get the right... Wait, what? I said the same equation as they did, though. I don't get it. One over root 2? Oh wait, that's cotangent. $54.7. What is that in radians? Nine 0.9547, 0.95532. I think that's a round. I'm willing to call that a rounding error. I hope, at least. I'm really dang close. I assume that's just a difference in how Desmos and Wolfram round. Doesn't that make things hard? Like, what if they're unprofessional teachers in schools? And I mean, so that's the case where people probably would do it or be more likely to do it if there's a bad teacher. But it's usually like, it's usually the type of parents who are like really pushing their students like, or their kids to do like a lot more. But yeah, it does make it harder. Integers, I'm not doing, okay, I'm giving you your points. I'm not even trying with that one, Skeleton. It's always something stupid like they're all one. No, that can't work. Oh, I've seen that exact problem now that you mention it. Yeah, I remember them being ridiculously huge numbers. I think someone gave it to me without warning me about it. So I'm going to say that I did this problem right. Oh, yeah, there is a minimum in the width friction, isn't there? Huh. Interesting. All right, well, aside from part A, I did that one pretty well. I think I gotta call the stream here though. Getting tired. So I think I'm gonna cut the YouTube stream off here, and then on Twitch I'm gonna look for a raid. So thanks, Trust Means and anyone else who's here on YouTube. I'll see you later.